What is the low frequency voltage gain for the amplifier shown? Well, the amplifier shown is a common collector amplifier. The way we can figure this out is by looking at the notes linked below the like button in the description on page 132, and we are going to get this equation for our voltage gain. Now, we are going to plug it into this second part right here. There are a few unknowns though. Actually, there's just one unknown, and that's our R pi. We don't know what it is. And our R pi can be rewritten. We've done this so many times before. But if we look here, R pi is equal to our beta over GM. So we're going to rewrite this as R pi is equal to beta over GM. And well, what is our GM? Our GM is equal to AI over V1, right? And we can rewrite this, we've done this before, as our IC divided by our VT. And so our IC is going to be 606 micro over our VT here is going to be 26 milli. So if we plug this into a calculator and divide this out, we have our 606 divided by 26, giving us approximately a GM of about 23.31, and this is going to be in, well, if we have a micro over milli, that's going to give us a milli. So now we can plug this into our GM right here, and our beta is equal to 106. Our GM is just going to be this 23.31 milli. We have 106 divided by 23.3, and then we are going to get that our R pi is equal to approximately 4.55. We want to bring our milli up top, so it's going to be in kilos, and for our resistance, it's going to be in ohms. So now if we take this and we plug this into a calculator, our resistance right here, we're plugging in all our values right into this top part right here. We have our beta as 106, our RE is 4 kilos, so that's 10 cubed. Our RB is given to us here as 0.4 kilos, so it's going to be right here. And then we have our R pi, and I actually made a mistake that I just corrected right here. This should be 4.54 times 10 cubed. This is our R pi that we're plugging in here, and then we have our beta plus 1, and then our RE. So with that all in there, we're going to get approximately 0.9885. So that means the answer for this problem is that our voltage gain is equal to approximately 0. And we can just round this to about 989. And that is going to be the answer for this problem and how we would go about solving it. Make sure to double check your work, make sure it is right, because originally it was incorrect how I plugged it in. Even though it's a small difference, it could still mean the answer being wrong or right.